Welcome to Secure 7. In today's episode, we'll break down one of the most dangerous web vulnerabilities from the OWASP Top 10, broken access control. We'll show you how it works, why it's so dangerous, demo real-world scenarios, and teach you how to prevent it. Before we break it, let's understand what access control is. Access control defines who can do what in a system: view profiles, edit posts, access admin panels, or delete users. Types of access control: role-based, RBAC, access based on user roles; attribute-based, ABAC, based on user properties; discretionary, DAC, set by the resource owner; mandatory MAC, based on system-enforced rules. When these controls aren't implemented properly, users can access or perform actions they shouldn't. That's broken access control. Let's say you're logged in as user A and your profile URL is /example.com/user123. But what if you change 123 to 124 and see another user's data? That's an IDOR, Insecure Direct Object Reference. With IDOR, attackers can view or modify data they shouldn't have access to: user emails, orders, invoices, even passwords. To find broken access control issues, ethical hackers use tools like Tools List, Burp Suite, Repeater, Intruder, Proxy, OWASP Zape, Postman for manual API testing, FFWFuzz for endpoint fuzzing, Autorize Burp plugin to test access with different tokens. These tools help test how the app behaves when different users try to access protected resources. There are several forms of broken access control. 1. Vertical privilege escalation. Regular user becomes admin, admin changes in cookies or roles. 2. Horizontal privilege escalation. User accesses another user's data, changing user ID in URLs or requests. 3. Forced browsing. Accessing restricted resources just by knowing the URL. 4. Missing function level. Access control API endpoint lets anyone delete a user or create an order without checks. 5. Bypassing access controls with method tampering, using POST instead of GET or JSON instead of form data to bypass logic. Now the big question: how do we prevent this? Implement role checks on every request. Every API call or route must verify user permissions. Use secure ID handling. Avoid exposing sequential user IDs. Use UUIDs. Deny by default. Block access unless explicitly allowed. Enforce access control on server side only. Never rely on client-side checks like JavaScript or hidden fields. Audit and test regularly. Use automated scanners, manual pen tests to catch gaps. Log and monitor access control violations. Spot strange behavior in logs before it becomes a breach. Broken access control is responsible for many real-world breaches. Real cases: Facebook, IDOR exposed user photos in private albums. Instagram, user data accessible by changing mobile API requests. GitHub, developers accessed repositories of other organizations. These bugs often go unnoticed but can be catastrophic. Let's recap. Broken access control happens when users access data or features beyond their role. Includes IDOR, privilege escalation, forced browsing, can be detected using Burp, Zap, Postman, and plugins. Prevented with strict role checks, proper session handling, and audits. It's one of the most common findings in bug bounty programs. Thanks for watching Secure 7. If this helped you, smash that like button, subscribe for weekly hacking content, and share it with your fellow learners. Next up, we'll cover cross-site scripting, XSS, another dangerous web bug with powerful impact. Stay secure. Stay ethical.